Hi everybody, this is Tony E at Show IP Interface Brief, and I want to give an update to the BGP challenge video that I posted 2 days ago. After I posted the video, I went ahead and included it on a tweet, and I went ahead and tagged Mr. Vinit Jain on it. To which he quickly replied, "Thanks, Tony. Just an FYI, you are making router 3 as part of Autonomous System 250, which contradicts the question. Have fun labbing." I think that's just a nice way of him telling me that I got it wrong. And when Mr. Vinit Jain tells you you got it wrong in BGP, you got it wrong. This guy wrote the book on troubleshooting BGP. I mean, quite literally, he wrote the book on troubleshooting BGP. Had I been a little more patient in watching his Cisco Live presentation, I probably would have seen this. Although I said that the topology was displayed at about the 12-minute mark, I admittedly did not watch the entire presentation. It was 2 hours long and I didn't watch it. I went back to that presentation as I thought maybe he gives the answer or maybe there's a clue or anything. And at about the 1 hour and 35-minute mark, he starts to allude to what the answer is. The too long didn't read version is inject and exist maps. Okay, so back here I have the lab built in GNS3. I went ahead and defaulted the configs. I have the basic BGP in here. Below here is router 1, router 2, router 3. This is router 4, and this is router 5. Okay, so there's still some basic connectivity we have to overcome. As I mentioned before on the first video, we're going to run into the IBGP split horizon rule, where router 3 is not going to send the learned prefix over to router 4. Anything that is learned from router 1, router 2 will send to router 3 will not send it to router 4. Any prefixes that are learned from router 1 and sent to router 2 is going to send to router 3 with a next hop value of router 1's interface IP address. So that means we're going to have to do a next hop self. And because router 3 will not advertise to router 4, we're going to go ahead and do the inject map here. So in fact, I'm only going to configure router 2 and router 3. We'll just do verification on 4 and on 5. Let's review our basic BGP configuration and dive right in. In the bottom left-hand corner, here we are at router 1. You see we have a dirt simple basic BGP configuration. Autonomous System 100, a single neighbor statement, and a single network statement. I am injecting the single prefix into router 1's BGP table. Over on router 2, we have only 2 neighbor statements, and we're in AS200. And in router 3, I am in AS200, and I have 2 neighbors, one upstream, one downstream, both in 200. Router 4, in the upper left-hand corner, I have 2 neighbor statements, one downstream at 200, and one over at router 5, which is in AS300. And over on router 5, I have a single neighbor statement. So let's verify on router 1, and we'll walk the path from router 1 to router 2, from router 2 to router 3, router 3 to router 4. On router 1, let's do show IP BGP. We have the prefix in here. It's chosen as our best path. I'm going to assume that's getting advertised over to router 2, show IP BGP. Router 2 is seeing that prefix as a best path. Let's come over to router 3, show IP BGP. Router 3 is receiving the prefix, but it is not choosing it as its best path. And if it's not chosen as a best path, he will not advertise it to router 4. Router 4 is receiving no prefixes. The reason this is not chosen as a best path is because it doesn't have a route. It doesn't have a valid path to the next hop. So if we do show IP route, we do not have a route to the prefix 10.1.12.1. So how do we fix that? Let's go ahead and put a next hop self on router 2. And over on router 3, we'll verify. Here we can see that our prefix is now chosen as a best path, and because it has a valid next hop. Over on router 4, now let's check to see if router 3 is advertising that prefix to router 4. Over on router 4, show IP BGP. It's still not advertising it to router 4, and that's because of the IBGP split horizon rule. Router 3 will not advertise this prefix, which it learned from an IBGP peer, to another IBGP peer. Over on router 3 is where we're going to do our inject and exist maps. In inject, and exist maps allow you to inject typically a more specific prefix from a larger if a larger prefix exists. And when it does that, it will originate it from its autonomous system that it configured on that router. As Vinit Jain points out in his video, this only works on iOS and iOS XE. It does not work on iOS XR. He had a great video. I did go back and watch it. It's very long. I learned a lot. Thank you very much for putting the content out there. It's on Cisco Live if anyone wants to sign in and watch that video. Okay, so how do we build an inject and exist map? We need three things. We need a prefix list identifying the learned prefix. We need a prefix list identifying the neighbor we learned the prefix from. And we need a prefix list identifying the prefix we want to inject. Then we need two route maps. One identifying the learned prefix and the neighbor we learned it from. And we need one identifying the prefix we want to inject. Let's go ahead and do that over on router 3. So I'm going to do a learned, and the prefix we learned is a single IP address, single host route. I'm going to build another prefix list and call this one neighbor, and our neighbor we're learning this from is 10.1.23.2, and that's a host. And the prefix we want to inject just so happens to be the same prefix. I'm going to call it originate. We're going to originate this prefix, and let's give it the same prefix. Now we have our three prefix lists. Let's identify these in our two route maps that we need. I like to call them route map inject, because this is going to be our inject map, and match IP address prefix, and this is going to be originate. Now we're going to do a route map, and I'm going to call it exist, and this is going to be our exist map. And here we're going to do, wait, let me back up a second. I see I've made a mistake here. Let me get in under the inject map. I have to change this from a match statement to a set statement. There, I feel more comfortable with that. Now let's build a route map for our exist. And let's do match IP address prefix, our learned prefix. And let's also do match IP route source, and this is going to be our neighbor. Now let's get under our router BGP config and do BGP inject, and our inject map name, and exist, and our exist map name. Now, I have found this takes nearly a full BGP update cycle to insert itself into the BGP table, and may take another update cycle for it to advertise over to router 4. So I'm going to stop the video here, let some time pass, and I will check on router 3 in just a minute. All right, everyone, we're back. I've waited a minute, and I went ahead and cleared the terminal screens. On router 3, let's verify we are now seeing the injected route. Show IP BGP. And here you can see we have our injected route. Here is our learned prefix. We learned this one from router 2 as it originates from router 1 and AS100. This is chosen as our best path because we are originating it locally. Now let's go over to router 4 and see if router 4 has learned this prefix. Show IP BGP, and not yet. So we still have the IBGP split horizon rule we need to overcome. How I did that was over here on router 3. I go ahead and make I go ahead and make router 4 a route reflector client. So I do that by saying the neighbor and route reflector client. Okay, those sessions will renegotiate over on router 4. I'm going to do show IP BGP, and you see we have the prefix here, but it is not chosen as our best path. So we run into the same problem here on router 4 where the next hop is invalid from router 4's perspective. Router 4 does not have a route to 10.1.23.2 we can see here in the routing table. So I'm going to go back on router 3, adjust the route map, and do a set IP next hop. I'm going to put this in the inject map. So set IP next hop, and I'm going to set it to myself, right? I'm going to set it to the interface IP of router 3. So when router 4 learns that prefix, it will have a connected route to router 3's interface IP. We get a little warning here. Warning, next hop address is our address. The reason it gave that warning is if we do a show IP route on our local router here on router 3, we see that the next hop is ourself. So we're essentially black holing that traffic if this was real traffic. All right, so let's go over to show IP BGP, show our BGP table, and we see we have two next hop values. For the prefix that we are injecting, we are the next hop. And for the learned prefix, of course, it's pointing back to router 2. We go over to router 4 and check the BGP table here. Now we see this prefix is now chosen as best path because it has a valid next hop, which points back to router 3. If everything goes well, this will be sent over to router 5. Let's check router 5's BGP table. And here we have it. We have our learned prefix with a valid next hop pointing to router 4. It's our best path, and it has a single AS number originating in AS 200. Guys, this was a lot of fun. This was even more exciting than the first one I did. What's funny is when I originally looked at this challenge, I thought to myself, I bet we have to inject a route somehow. And I just couldn't figure out what was the correct combination of configs to put in to make that happen. So I went down the path of doing AS override and local AS, no prepend replace, which I got called out on and ended up being I thought it was a valid solution, but the author did not. So let's go with what the author says. Thank you, Vinit Jain, for commenting and forcing me to try to do things the right way. Thank you for all you've done for the community. Great videos, great books. Thank you very much. I hope everyone has enjoyed this. If there are any other ways to take care of this, to solve this, again, please post a comment below or let me know. Thanks for watching.